This is the birthday paradox. It states that if you have 23 people in a room, there is almost exactly a 50% probability that two of those people will have the same birthday. Most people would call this a paradox because there are 365 days in the year. So having only 23 people in a room seems like it would be pretty low probability that two of them would have the same birthday. So I'm going to show the equations that explain that. This problem requires two equations. One equation I'll derive here, and I think it's actually a very simple equation that pretty much anybody could understand or derive themselves once I show how to do it. And then the other equation I derived in my previous video on if a second attempt doubles your odds. That equation is actually also really easy to derive, so you can see that video to see how to derive that equation if you wish. So I'll just jump right in and show how to explain this paradox. Let's say you got 5 people in a room total. What are the ways that those 5 people could pair up? Or you could have, in other words, it's a 2-person combination. Or if you have 5 cards from a deck, what are the different ways that you could put those cards together in pairs? So you could describe this as different ways to pair up, or the different number of combinations, or the different attempts to pair up. How many times can you attempt to pair up? And that attempt is an important word. I'll explain what that means. Let's say we have 5 cards in a deck. What are the different ways that you could put those 5 cards together in pairs? So let's look at the first card right here, labeled as 1. You could pair it up with 2, 3, 4, or 5. Next, we look at card 2. We could pair that up with 3, 4, or 5. We could also pair it up with 1, but we already included that up here, so we don't include any more 1s. Now we look at our third card. We could pair it up with 4 or 5. We could also pair it up with 1 or 2, but we already included that up above, so we don't count that again. Then we end up with 4 or 5. So as you can see, you just go 1, 2, 1, 3, 1, 4, 1, 5, 2, 3, 4, 5. And then you go to 2s, 3, 4, 5. You go to 3s, 4, 5, and so on. So this is how you can pair up your cards if you have 5 cards. So there's actually this many combinations. You can actually count them up like this. It goes 1 plus 2 plus 3 plus 4, 1 plus 2 plus 3 plus 4. But you could also say this is the number of attempts for a person in a room to pair up with someone else. So say you got 5 people in a room, and one person really likes strawberry ice cream, or maybe one person has one brown eye and one green eye, something really rare like that, or it could be something really common. Either way, he has to try to pair up with somebody else in the room that has that exact same quality. And of course, it could be the same birthday as well. So this is person 1, let's say. He goes over to person 2 and says, "What's your birthday?" or "What's your favorite ice cream?" And it turns out it doesn't match up. And so number 2 says, "You're all right, mate. Go ahead and try somebody else." So then person 1 goes over and tries person 3 to see if they pair up. They have the same birthday or the same eye color or whatever. Then same thing with 4 and 5. Person 2 does the same thing. They try to pair up with 3, 4, or 5. 3 does the same thing. So every number or every person tries to pair up with somebody else. Or technically I should say that every person tries to pair up with every other person in that room. So in other words, the number of combinations you have right here from those 5 cards is also the number of attempts to pair up. And this forms a nice formula with the sigma notation or summary notation. N equals 1 right here means you're starting with 1, and you end with, and that's actually not N right here, that's total. Total minus 1. The total in this case is 5. So 5 minus 1 is 4. So you start with 1, you end with 4. You just go and end right here. So you go 1 plus 2 plus 3 plus 4, and that is your number of attempts to pair up or your number of combinations. And right here, N equals 1. So we start with 1, end with 4. So 1 plus 2 plus 3 plus 4 gives you 10 possible combinations or 10 possible attempts to pair up. Now let's look at the, I'd say somewhat famous number now of 23, because I've seen this in several videos. If you have 23 people in a room, there is a 50% chance that 2 of them will have the same birthday. So total minus 1, so 23 minus 1 equals 22. Sigma notation, starting with N equals 1, going to 22. That means that's 1 plus 2 plus 3 plus 4 all the way up to 22 equals 276, and that is your number of attempts to pair up. So that is that formula that I just derived. The other formula I derived on the other video was your chance of winning with multiple attempts. So we take 1 minus the probability of losing, so losing over total, to the exponent of the number of attempts. So we have 1 minus 364 out of 365, because that is your probability of losing. Take that to the number of attempts for the exponent, 276, you get 50%. And again, if you want to see my other video on how I derive that formula, like I said, it's pretty simple and almost self-explanatory, kind of fun. Next page. You could do 30 people, so on top of your sigma, just write 29, go through the same procedure. If you have 30 people in a room or 30 people in a classroom, 70% probability that 2 of them will have the same birthday. And I think that's interesting because going through school, most of our classes had about 30 students. So most of the time, 2 of those students in that class, there'll be at least 2 students that have the same birthday. That's kind of fun. I also think of going into a restaurant, say a smaller restaurant that isn't very busy, and there's only 30 people in there, 70% chance that 2 of them have the same birthday. And I just want to be clear, this isn't the same birthday as you, it's just 2 people in that room have the same birthday as each other. Let's go into a little larger restaurant, or maybe a movie theater that isn't very full with only 60 people. Go through the same math. There's a 99% probability that 2 people in that restaurant or that movie theater have the same birthday with only 60 people. So I think that's kind of cool.